So let's go to the first presentation that may be relevant to what we do here today. And I think I'd like to talk about things specific to the latest topics in our discussion were inheritance and composition, interfaces and abstract classes, then specifically inheritance and generalization, aggregation between classes, associations, and cardinality of these associations. So these are essentially all of these things are principles that we use to put together classes and to describe how do they relate to one another, what do they know about one another, and what they can possibly do with one another at runtime when the structure is in place. So by looking at this high level, just the topics itself. So why do we discuss inheritance along with composition? Well, because what we just were mentioning here is that when we have, this is a physical picture of the savings account class that has this inner part, which is an account part. Okay. As you can see, because savings account originally derives from the account class. If you look at this, you'll realize that inheritance is one of the ways to reuse code. And precisely, this is the reason why we didn't have to redo anything in the savings account that the account already knows how to do or what it stores. Because savings, this relationship that says savings account is also an account, or savings account is the generalization of an account, or actually vice versa. Savings account is more concrete representative of an account class, right? So from this perspective, this is a way to reuse code, reuse data, right? Because if an account already exists as class, all it takes to inherit everything from it and get everything from it in terms of public interface and all the data that it contains is simply say savings account extends account when we create Java class in our Java source file. In C++, very similar syntax. Just say class savings account, and there's a colon symbol that represents inheritance, and same thing, you specify the account class. Very similar syntax. So because inheritance is most certainly a form of reusing already existing software, in particular a parent class or superclass. Composition is another version of a reuse where you say, where essentially what you have is to have a bigger part made out of smaller parts. And in that sense, inheritance is not a good way of expressing it, because typically, and especially in Java, if you look at our diagram here, you cannot really derive or savings account can have only one parent class. Java doesn't support multiple inheritance like this. So if I had another class named insurance, okay, so if for some reason if I wanted to insurance policy, okay, insurance policy, if I wanted to somehow make sure that savings account is automatically insured, one of the ways to do this for me would be to create an insurance create an account, create an insurance policy, and simply tell my savings account that, hey, why don't you inherit from two of these, right? Inherit from the insurance policy and also inherit from the account. Now, if this would be possible to do in other programming languages, Java doesn't support multiple inheritance, right? In this case, what would be possible with Java would be to do something like this, to maybe make account deriving from insurance policy, and then in its own turn, savings account deriving from the account. So account is the superclass of the savings account, but account is a subclass of the insurance policy. Then I can, of course, reuse it, because then what happens is that if this is the savings account, this is the account, then maybe, and let me kind of try to thicker drawing here, then inside of the account I would have a smaller box which would be, you know, which would be my insurance policy. So this is the insurance policy, this is the account, and this is the savings account. So I have like three nested boxes on this picture. Okay, so that would be a possibility. However, it may not necessarily make sense from the business perspective. So business people might say, no, we don't feel comfortable saying that account is an insurance policy. That's a wrong statement to make. But that's exactly what this UML diagram does right now. It says savings account is an account. That makes sense. Account is an insurance policy. No, that's wrong. Wrong statement. Doesn't work. So therefore, we go ahead and we remove, maybe, we just say, let's remove it. But if we truly wanted to make sure that savings account derives from the insurance policy, what we could do in Java is this. We could just say, okay, let savings account derive from the account class. Let me actually rearrange this a little bit so that everything is sort of like, you know, in best readable form, I would say. So what we could do, we could create an interface and name it policy or insurance policy for the sake of the brevity. I will just say create an interface, then implement the interface by the insurance policy class, and then have the savings account also I'm thinking, what would I do? I can I can then also say what I could do, that I could probably say that my savings account also implements this interface policy, but in the constructor of my savings account actually create an insurance policy and basically delegate all this insurance policy work to this insurance policy class. So and you know, it may not be immediately obvious what I'm trying to work around here, but this is one of the restrictions, is that you can have multiple inheritance based on interfaces in Java, but not based on inheritance from classes. Perhaps to demonstrate multiple inheritance, I could perhaps, you know, after we do some more talk, I can show you how it's done in C++. I can just write a sample here that you can see a multiple inheritance example based on C++ code. We could do it today. So anyway, interfaces play a very important role in Java programming. So interfaces can be used, but they need to be implemented someplace. And our discussion started from the idea that composition is also a form of reuse. So composition, as opposed to inheritance, could be used here simply like this. So instead of playing with insurance interface, I can get rid of all of this, create insurance policy class, and then simply have a savings account, just have access to, just use simple association, and say that a savings account has access to the insurance policy. Right? So then if savings account needs to do any work related to the insurance of that account, it will basically communicate with an insurance policy class. Most likely our savings account will create an instance of insurance policy class and will have its, its connection to it at runtime. And anytime there's any work related to insurance policy, we can delegate that work to insurance policy. This is actually an aggregation by association, but you can also specify that the aggregation could be made stronger through the to specify. For instance, right here, you can say that I want an aggregation. Typically, aggregation association indicates that having a savings account without insurance policy would be a dysfunctional structure. So this rhombus that basically says this part, savings account, requires insurance policy as part of its functionality. It's called aggregation relationship. In this case, basically what it indicates to the reader of the diagram is that most likely using the savings account without having insurance policy class available is illegal and totally dysfunctional.